All right, guys and girls, moving on to number 15, test 2, section 4. This one looks like we got a little bit of converting equations going on here. We have the distance. They're telling you the distance traveled by Earth in one orbit around the sun is about 580 million miles. So they're giving you a distance. Now, there's a couple of ways we can really treat this, and that is one of them. They're giving us a distance. Earth makes one complete orbit around the sun in 1 year. Hopefully you already knew that. But of the following, which is closest to the average speed of Earth in miles per hour? So they're wanting a rate or a speed. So there's really a couple approaches you can take to this problem. One is to look at it this way. They're giving us a distance, they're asking for a rate, and they gave us the time, 1 year. You can do this as just a good old distance equals rate times time. That is one way to approach this. The other way is they're telling us the rate is in miles per hour. So you can also think of miles per, so I'm going to go miles per hours. So you're going to divide both those numbers because the word per means divide. So either way you look at it, you're going to kind of get the same equation because notice miles is a distance and hours is a time. So if you want to solve for the rate, you're going to go distance divided by time. So either way you're really looking at this, they're both going to get you where you need to be. So looks like I need to take my distance divided by time. However, you need to make sure when you do it that you have miles and you have hours because that's the rate we want. So they are giving me the miles. So again, either way, it doesn't matter how you're looking at this. I'm going to take my miles, which they told me is 580 million. So that's a lot of miles. And I need to divide that by the number of hours. Well, they're saying what's the closest average speed in miles per hour as it orbits the sun? It orbits the sun in 1 calendar year. So what we want to do, and again, they say which defines closest to. So there are some technicalities here and how many days, we got your leap years and things like that. I'm just going to say 365 days, okay? But what I want to do is say in 1 year, 365 days, how many hours are there? So to get my hours, I'm going to take, in this case, 365, that's the number of days, times 24. And that's going to tell me how many hours I have in a year. So 365 times 24 is 8,760 hours. So that's what's going to go up here. So 8,760. So we're dividing those two numbers, miles divided by hours, to get our rate. So I'm going to go 580 and then 6 zeros after that, divided by that number. And we get approximately, again, this is approximate, and that's okay, 66,210 miles per hour. So we want to find what's closest to that. Well, if you notice, that is answer choice A. So your answer for number 15 is going to be A. So that's 15. 16 is giving us a chart. They're telling us how many students have passed an exam and did not pass an exam based on if they took a course or not. So we're looking at a review course. I don't have to read this whole chart. It's a two-way frequency chart. If I see a two-way frequency chart, good thing, it's a good chance they're going to be asking about, and that's what they're doing here, probability. So what I need to first off have is that 1882. I need these numbers. It's an ugly 8. There we go. 1882, 793. But what you normally need on these, you also need to have your totals. Now, I don't need to find every total. Let me see which total I actually have to find. But that's what they are leaving out. There's usually total columns and rows here. Sometimes there's a grand total kind of goes at the bottom where these numbers meet. But this one, I'm just going to go to see what they want. What is the probability that a person did not take the, so if one of the surveyed graduates who passed the bar exam, so we're looking at these students right here. Therefore, these students don't matter for what we're trying to do. So out of these students right here, so 18 plus 7, so 25 students, out of those 25 students, what is the probability that the person did not take the review course? So we have to not take the review course. There's 7 students. That is your desired outcomes, divided by your total possible outcomes. Well, your total possible outcomes is this number 25, and we're just looking for that answer. That's all we're doing. You just have to make sure you pull from the right pieces of data. So that's going to be answer choice B. So that is number 16. So that's 16. Moving on to 17. 17 says they're giving me atomic weight of an unknown element. So the atomic weight of an unknown element in atomic mass units is approximately 20% less than that of calcium. So when I see the phrase 20% less, here's the first thing I'm thinking of. I'm thinking of the decimal 0.80 or 0.8. I'm probably actually going to be using that number. They say percent less, subtract from 1. They say percent more, you add to 1, but that's not what I'm doing here. So I'm going to be using that 0.8 more than likely in this problem, in the solution. So the atomic weight of calcium is 40. So what is the best approximates the atomic weight of the unknown element? Well, I have atomic weight of calcium is 40. So there's your calcium weight. Now with this weight, they told me the atomic weight of an unknown element is approximately 20% less than that of calcium. So it is 20% less, so 0.80 of, in this case, than that of calcium. So what I'm going to be doing, so this unknown element, I said I wrote this out wrong, so let me fix that. And I'll fix the whole thing. So I'm kind of doing a little bit of converting equations here. So we have an unknown element, so I want to call that unknown element X, is 20% less, so 0.80. It's 20% less than that of calcium. And calcium, they told me, was 40. So we're multiplying 0.80 times 40. Remember the word is. This word is going to mean equals. So when I see that word, I know, and this I know to set an equal sign, and this is usually represented by the word of. And I kind of have both those words in this equation. Even though you don't need to use that method, it does help kind of solidify things. So I'm just going to multiply those together, and you get 32. And 32 is C. So that is number 17. Let's keep it moving. Number 18. This one says a survey was taken of the value of homes in a county. It was found that the mean was 165,000. So I got a mean. So I got 165,000 for the mean. So that's the average. And then they're giving me a median, which is the number in the middle, if I kind of put all this data in here. And that median value was 125,000. So this is going to be one of those process elimination problems. Just they want to know which of the following situations could explain the difference between the mean and the median. Now you can do a little bit of speculation here. If I had a list of numbers, the number that would be right smack dab in the middle is at 125,000. That's 125K. But your average is out here somewhere. Now, that should tell you, and it's a lot bigger, that should tell you that there's probably going to be some outliers, and I call these really big numbers. There's some outliers out here that it's driving the average up. So you may have a bunch of numbers that are maybe in the 120 to 115 range or whatever, but then you may have some like 250, 300,000 out here, because that's what that's going to do is it's going to make the average bigger because it's kind of pulling the numbers this way. So that's what's happening here, and you just want to go through your answer choices and see which one would match the scenario the best. And again, it does help to speculate a little bit because it can help you see what answer is going to be correct. But again, you should be doing something like this as you go through, eliminating answers that don't match what fits the data. But C is doing what I just said. It says there are a few homes that are valued. There are a few homes that are valued much more than the rest. That could make sense because we have some outliers that are dragging the average up, and that C would let that happen. So that's going to be your answer for number 18. Number 19 gives us this chart, and I kind of did an abbreviated version of the chart, which I didn't draw the whole tables and stuff or the lines, but this is all the same data. So a couple things about this chart. Obviously it's telling me the number of siblings at 2 different schools, but they're telling me that there are a total of 2,400 students at Lincoln High School. So I'm going to kind of put this off to the side here. So Lincoln High School, again, we have 2,400 students. And Washington High School, that's going to give me 3,300 students. Okay, so that's some additional information that's not in the chart itself. So all this stuff's really important. It really, really, really is. So when you have these problems, again, 19 and 20, they come in pairs. You have to read that paragraph in any chart and data. You have to read all the details because you're going to be using most of it, if not all of it, as you go through the two problems. So with this information being said, it says, what is the median number of siblings for all the students surveyed? So again, the median number, that's going to be that middle number. So in this case, the middle number, so again, I'm looking at a median. In this case, the median, you have to figure out, there's a lot of students here. So what I want to do is not try to put them all in order. What I mean by that, what's a median number of siblings? I don't want to go 0, 120 times and then 80 times, and I don't want to have to go 0, 0, 0, 0, 0. That would take forever. What I do want to do is figure out how many students are there in this survey, and say there's 1,000. There's not. Well, then the 500th student is going to be my median student. So I just got to figure out how many there are total, and then whatever number would be in the middle of that, how many students would that sibling have, or how many siblings would that student have. So if you don't understand what I'm saying, let's kind of fill out a total column real quick, and you'll see what I mean. So I'm going to fill these out. That's 20, that's 40, 90, that's going to be 190, and that's going to be 260. So what you do is you figure out how many students are surveyed. And you add all these up. I've already done that math, so that's going to be 600 students total. So I have 600 total students. So the median in this case is going to be my 300th student. So the question should say, if you put all these students in order from 0, from the least number of siblings to the greatest number of siblings, in a row, there'd be 600 students. How many siblings would that 300th student have? So that's where you want to look over here. Well, the first 260 students would have no siblings. So somewhere in here, because the next 190 students in that row would have one sibling. So obviously the 300th student would have one sibling. So here we're looking at one sibling. And that is the answer for number 19. So that's going to be B. My 300th student has one sibling, and B matches that. So that's going to be, again, 19. Keep it going. Number 20, using the same set of data, it says, based on the survey data, which of the following most accurately compares the expected total number of students with 4 siblings at the 2 schools? So what I want to do is figure out how many siblings there are, approximately, at the 2 schools. Well, this data we found earlier here, that's going to be super important to help us find this, because there's not actually 300 students at each school or 600 combined. There's really this many numbers. So this is actually a conversion question. We want to do a conversion to the actual number of students. And I'm focusing on these students that have, and I think they said 4 siblings. Yes. So I'm looking here at these students. So I'm going to do 2 schools here. I'm going to do Lincoln High School. I'm going to figure out approximately how many students have 4 siblings at that school by doing a little ratio. I'm going to go 10 out of however many students there are total, and I believe it was 300 for both. Yes, so it's going to be 300, and that makes that 300. And you just got to add these up to see if there's a difference between those 2 schools, and there's not in this chart. So 10 out of the 300 is going to be equal to X students out of Lincoln High School has 2,400 total. So I'm going to solve this, and I actually can't simplify that a little bit. That's 1/30. And again, using a calculator would be helpful here. So this would be 30 times X equals 1 times 2,400. I'm using cross product property. I'm just going to divide both sides by 30. So that gives me 80 students. There's 80 students at Lincoln High School that have 4 siblings. Now, going to Washington High School. So I'm going to do the same thing here. It's still 10 out of 300, but that now equals Y out of, and in this case that number is different. It's going to be 3,300. So I'm going to do it just like I did before. Cancel out a factor of 10, so that's now 1 over 30. So I'm going to have 30Y equals 1 times 3,300. And then I'm just going to go 3,300 divided by 30. and y is 110. So even though these numbers are the same, it doesn't mean that our actual numbers will be the same, because these are 10, and there's more students. It's not the same number of students. So you'll see that's kind of affected here. So we're just going to go through our answer choices. A says the total number of students. And let me just kind of put my answer choices here, and we cross out as we go. So A says the total number of students of 4 siblings is expected to be equal. That's a great trap. Notice it's answer choice A, but it's not true because the total number of students is different, so that affects your proportion. Next up, the total number of students with 4 siblings at Lincoln High School is expected to be 30 more than at Washington. So saying Lincoln is 30 more than Washington, well, that's actually opposite. It's 30 less. So B is out. C says the total number of siblings with total number of students with 4 siblings at Washington School is expected to be 30 more than Lincoln, and that's what we have, and that therefore is our answer. So number 20 is going to be C. All right, and 21. 21 says a project manager estimates that a project will take X hours to complete. So I'm going to start off here. I'm going to just go ahead and write that down. We got X hours. That's an estimate. I could put a question mark there, but that may be confusing too. So I got X hours to complete, where X is greater than 100. You'll notice that doesn't matter, but we'll just go with it. The goal is for the estimate to be within 10 hours. So I have this estimate, and it's going to be plus or minus 10 hours, because it has to be within 10. Okay? So it's 10 hours of the time it will actually take to complete it. So the manager meets the goal, and it takes Y hours to complete. So we have Y hours. So I'll say Y actual. That means actual hours. These are all our relationships here. Which of the following inequalities represents the relationship between the estimated time and the actual time? So what you can do to help yourself here, to help yourself figure out what's going on, I always say, like, you can see the answer, and that's great if you can interpret this, but you can always plug in numbers. What I mean by that is just pick some numbers, plug them into the equation. You know what should be happening, so we want to get a true estimate of what our answer should be. So what I would do if I was going to pick a number, and again, I said that 100 doesn't really matter. Like, why does it have to be 100? It doesn't. So I'm just going to call Y 100, and we'll say it took 100 hours to complete. So therefore, your estimate, when you're looking at your estimate and you go plus or minus 10 hours, that means it could have taken you either anywhere from 110 hours, I'm kind of going backwards here, but whatever, to 90 hours. These are the estimates that you would be given. So your estimate has to be between one of those two numbers. So we're plus or minus 10 hours. So when you look at these inequalities, again, there's no real set scenario. They're just looking for an inequality that works. Okay? So if you have some numbers to work with, you should be able to tell which answers would work here. So again, remember X is the time that estimated. So we can pick 90 for X, or we can pick 110 for X, or anything in between. So if I'm doing like X plus Y, and again, I'll just put my answer choices here. If you're adding X and Y, we're looking at two numbers that are fairly big, because Y is 100 and X is somewhere between 90 and 110. Well, those aren't going to be less than 10. So that's definitely ruled out. Y, if I was looking at B, you say Y is greater than X plus 10. I mean, Y is greater than, if I go X plus 10, I can go 110 plus 10, and that's not true. So I can rule that one out. So we're looking at C and D, and this is just nice if you have numbers to work with. Notice you can play around with that X value. C, we have Y, which again I'll say is 100, is less than X minus 10. So X, I'll just go 90 or 110 minus 10. And notice they'd be equal. And I don't want to be equal, I want to be less than. And I do know that I am picking numbers that, it has to be, it can vary. But like I said, you want to try to find a way to eliminate it, because you should only have one answer that always works. So then if you look at D, we have negative 10 is less than Y minus X. So I want to, and by the way, when I plug this in, that's in between negative 10 and 10. It's just making sense. You got that plus or minus in there. But again, you are looking at y minus x. Well, y is 100. And even if I went both extremes, minus 110, well, that's going to give me negative 10. And again, I am picking numbers. I know it has to be between plus or minus 10. It'll take x hours to complete. So we're looking at, it has to, when they said that phrase within 10 hours, that kind of actually fits this because, yeah, this is equal and these are not supposed to be equal. But they said within those 10 hours. So within means it's actually a little bit less than that. So I'm picking the number it's equal to, but it actually has to be slightly less. But that's fine if I can make these equal and I know it's within, it would fit the inequality. So that would fit that negative 10, even though I know this number has to be a little bit less than 110, which would make this difference less than negative 10. It'd be like negative 9.9 or something like that. Here I can also go 100 minus 90, which is 10. And again, that would fit as well because it has to be within 10 hours. So this one fits both scenarios. So we're going to go with the D, and that's going to be your answer for number 21.